So here is an interesting application of our quotient rule. First, we must find a point. So when x equals 2, we can say that the function value at 2 is 2 over 2 minus 1, just plugging that into f of x to give us 2 over 1 or 2. So the y value, f of 2 equals 2, it means our xy point is 2, 2. There's an xy point. So we're halfway there if we're going to substitute into y equals mx plus b. So our derivative here will give us our tangent line slope. And recognize we're going to have to use the quotient rule here. Derivative of the numerator times the denominator minus the numerator times derivative of the denominator over the denominator squared gives us x minus 1 minus x over x minus 1 squared, which is negative 1 over x minus 1 squared. That is f dash of x. We are interested at this point, x equals 2, which means we'd like to find f dash of 2. So I'm going to substitute that into when I substitute 2 into this equation, I get negative 1 over 2 minus 1 is 1 squared, which is negative 1. So I've got a point, 2, 2, and a slope. And so if I'm going to substitute into y equals mx plus b, I'd like to know what b is. I know that y is 2, I'm getting that from there. M is negative 1, x is 2, because they told me that, plus b, to give us 2 equals negative 2 plus b. If I add 2 to both sides, I get b is equal to 4. So my y-intercept is 4, and my slope is negative 1. So y equals negative 1 x plus 4 is my final answer, because I found my m, my slope, is negative 1, and I went and found my b as 4. So here's another example of an application of the quotient rule. Y is equal to 2x over 3e to the x. Find the equation of the tangent line when x equals 0. So when x equals 0, I'd like to find my y point. Y is equal to 2 times 0 over 3e to the 0. Now, e to the 0 is 1. So this is 2 times 0 is 0 over 3 times 1 is 3 to give us 0. So our point is 0, 0. That's x comma y. Let's find our slope. First, we have to find the derivative, and then the derivative when x equals 0. So y prime, or I'll call this f dash of x because we're going to find f dash of 0. Maybe it's easier than that. The derivative of the top is 2 times 3e to the x, that's the bottom, minus 2x, that's the top, times the derivative of the bottom, everyone's favorite function, 3e to the x, over 3e to the x, the whole thing squared. So our derivative is 6e to the x minus 6x e to the x over 3 times 3 is 9. E to the x times e to the x, we've seen this before. E to the x times e to the x is e to the 2x. That's how I'm getting this down here. E to the x squared is going to be 9e to the 2x. So even if I left it like that, or let's say I factor out the e to the x. So if I bring out e to the x, I'm left with 6 minus 6x over, this is e to the x times 9e to the x. So these will cancel, and this is my derivative. F dash of x is equal to that. Now, I want to find the derivative when x is 0. So I'm going to change this to 0, and every time I see an x, I'm going to put in a 0, and this is e to the 0. Now, so important for us to know that e to the 0 is 1. Anything to the 0 power is 1. 6 times 0 is 0, so 6 minus 0 is 6 on the top. 9 times 1 is 9, so this gives us a slope of 2 over 3. So we can go back now and say our equation is y equals mx plus b. I already know my y-intercept, so I've put a 0 in for x and a 0 for y. I get my b as 0. So The only thing in this equation I have to worry about is the slope. Y equals 2/3 x is our equation there. Note, if the point goes through 0, 0, the b is 0. We didn't have to do much work for that.